Ahoy RobotX community. We are team SINGABOAT-VRX from Nanyang Technological University, Singapore. We have configured our WAM-V with 4 thrusters in X configuration and a comprehensive sensor suite comprising of 3 RGB cameras, 2 of which can be collectively used for stereo vision, a 3D LIDAR, a GPS receiver and an inertial measurement unit. Apart from these, the autonomous surface vehicle also hosts a small cannon to deliver a projectile payload. We employ our ASV to address 6 different tasks in the order of increasing complexity pertaining to different aspects of autonomy, including perception, planning as well as control. The first task is that of autonomous station keeping, wherein the ASV is initialized in a drifted state. It has to localize itself within the environment and then drive towards the goal and maintain its pose thereafter, taking into account the environmental disturbances such as waves and wind. The second task is that of autonomous navigation, wherein the ASV has to track a series of waypoints while localizing itself within the environment. The controller is meant to track both position as well as orientation of the ASV with respect to each waypoint. The third task specifically targets the perception module, wherein the ASV has to employ its exteroceptive sensors like cameras and LIDAR to detect, characterize and localize various objects in the sea. The perception pipeline has to be robust enough to deal with uncertainties pertaining to vehicle motion, sensor noise and environmental variations such as lighting and fog. The fourth task is that of semantic navigation in an augmented wildlife scenario populated with virtual animal markers representing 3 different types of wildlife: platypus, turtle and crocodile. The ASV should detect, identify and localize these wildlife elements and plan and execute a trajectory that circles clockwise around the platypus markers, counterclockwise around the turtle markers and avoids the crocodile markers by maintaining a safe distance from them. The fifth task involves channel navigation, obstacle avoidance, acoustic beacon localization and station keeping. The ASV has to first navigate across a channel defined by red and green buoys. After crossing the channel, the ASV enters into an obstacle field comprising of black and orange buoys. It has to localize and drive towards an underwater black box containing an acoustic pincher without colliding with any of the obstacles. Once the distance to the black box is minimized, the ASV has to maintain its position thereafter. The final task is called Scan Dock Deliver, wherein the ASV first approaches the light buoy and scans the light sequence to determine the appropriate bay for docking. It then approaches the docking bays, identifies the correct one and executes a safe and controlled docking maneuver. The ASV has to then launch a projectile payload through one of the 2 holes in the placard at the head of the correct docking bay. Finally, the ASV has to exit the dock safely.